Please welcome James Tralie, producer and animator, NASA Goddard Space Flight Center.
How's it going? Thrilled to be joining you today. Thanks so much. Thanks so much for coming. Yeah, so I'm James Tralie, and I'm a producer and animator at NASA Goddard Space Flight Center. And today I want to talk about some of the science communications work we do as sort of NASA's in-house video production agency. So how do we tell NASA's stories? So there's a couple different ways we approach this, and a lot of stories sort of write themselves for us in many ways, like new image releases from the James Webb Space Telescope. We know they're already going to be incredibly inspiring, so it's not too heavy a lift for us to kind of get those out to you to really get you excited about the work we're doing. We also talk a lot about the incredible engineering marvels of our mission. So things like the OSIRIS-REx spacecraft a couple years ago, navigating itself to the surface of asteroid Bennu to collect a sample that it's now actually bringing back to us here on Earth. So mark your calendar, September 24th of this year, we're going to be delivering that sample to the desert in Utah. We're actually going to be transporting it to Johnson Space Center in Houston to open up and analyze for generations to come. We also want to keep you clued into new happenings at NASA, so new missions in the pipeline. So things like the Da Vinci mission, which is going to be exploring Venus like never before, plunging through the Venus atmosphere down to the Alpha Reggio Highland region. Or the Mars Sample Return mission, which is an enormous collaboration with the Jet Propulsion Lab, as well as the European Space Agency, to get a sample back from Mars that's actually currently underway right now with the Perseverance rover collecting samples from the Martian terrain. We also, and most importantly, want to tell you about the people behind the magic. And this, for me, over the past couple years of covering NASA science, has been one of the most rewarding parts of the job, is really just telling the story of these amazing scientists and engineers who are involved in getting us out to space deeper than we've ever explored before. So how do we actually quantify the importance of our work? I kind of break it down into a couple different buckets. The first is the distribution. Obviously, we want this content to get out to you and have you clued into what we're doing and be able to access our content. And we do this in a number of different ways. So obviously, you probably come across our content on Instagram, YouTube, Facebook, Twitter as you're scrolling through your feeds. But we also want to make sure that it's downloadable and reusable for you, the public. So we make a lot of our content available on a site called the Scientific Visualization Studio that I've linked right here, the SVS. And so every piece of our content, animations, visualizations, graphics, images, they're all Creative Commons downloadable. And actually, I noticed a couple of our animations in the opening dramatic montage that we had at the beginning of the conference. It's cool to see that there as well. Another big angle of our work is the documentation aspect of what we do. So this involves a number of different aspects. We're really there with every single mission from every single step of the way, from its initial conception and planning to design and testing and engineering to actual launches and deployment of our spacecraft out in space. And then once it's out there, collecting amazing science, doing amazing research, we're there capturing that every step of the way. So it's a really incredible experience to be there on the ground and kind of shepherding these missions along and then actually translating that science into video productions for you, the public. We also jump in front of the camera quite a bit, so I've included a couple pictures here of some productions I've done for NASA in support of some of our missions as this science is unfolding in real time. So things like I mentioned the OSIRIS-REx mission landing on an asteroid, collecting a sample, or working with our scientists like Dr. Noah Petro, who's pictured here, who works with the Lunar Reconnaissance Orbiter as we're mapping the moon like never before. And then the last angle of our work, which is often really hard to actually quantify, is the inspiration. I think a lot of us are here today because of how we've been inspired by NASA missions over the past decades of our agency's inception. You know, things like the moon landings from the Apollo missions, or landing rovers on Mars, or incredible images from the Hubble Space Telescope. And now we're really inspiring the next generation of scientists and engineers who are going to be taking these same roles and maybe being at this conference in 10, 20, 30 years' time and kind of continuing our push, our march deeper out into space. And so it's really hard to understate the importance of that inspiration aspect of the work we do. And it's certainly what inspired me to join this role as well. So over the past couple years of covering NASA science, I've been able to kind of have some pretty cool experiences, like actually going right up the road here to Kennedy Space Center. If you've not been there, definitely get a chance to see a launch. There's one this weekend that's coming up that should be really cool. But really cool experience there. This picture is from when I was out for the Lucy spacecraft launch a couple of years ago. I've also gotten to meet some cool people along the way, like a real life-size Lego astronaut when we had the 50th anniversary of the Apollo moon landings. There's a huge celebration out on the National Mall in DC where we had a big projection up on the monument, kind of a really cool experience there. And then, there are just so many different missions that we cover as part of the planetary science sphere. I've just included a couple of these really cool logos that we have for all of our missions. And this just kind of shows just a small portion of the incredible science that NASA is really doing. And to be there as this is happening in real time has really been just an incredible honor. And so I wanted to actually walk you through how we shepherd a piece from what every single thing starts with, the science, down to a finished production that you'd come across on our social channels. So as I mentioned, every single piece we do begins with the science, and science is at the core of every single production. We want to make sure we're telling an accurate story, an accurate depiction of the science and engineering that's going on. And so we work directly with the scientists every step of the way, checking our results, even as we kind of push things a little bit more creatively, as you'll see in a second here. And so once we kind of have an understanding of often the very jargon-heavy papers here, we'll move into the storyboarding and planning phase, where the magic starts to kind of happen here. And so I've included an example of one production I worked on recently for the MAVEN mission, which is exploring the upper atmosphere of Mars, where we kind of pushed it a little bit into the Spider-Verse, kind of like a comic book style animation, where we were able to really tell this incredible story of the work that's being done with this mission, but keep you engaged in an interested way here with the science that we were doing. And so once we kind of have an initial script, initial sketch apart here, we'll move on to the production pipeline, which really takes a variety of different formats depending on the work we're doing. So oftentimes, as I mentioned, it involves being there in the labs as these spacecraft are being constructed and tested. This picture in the top here is when I was actually out at White Sands Test Facility, and you heard a little bit about this test facility this morning from Jared, where they're actually using these massive guns, they're the size of a building, to get up to speeds as close to like 10 kilometers per second, blasting our spacecraft exteriors to test to make sure that they'll hold up in the very tough atmosphere of space. In this particular case, they're testing for the Mars sample return mission. So as we're coming back with those samples from Mars, we want to make sure that our spacecraft is not shredded apart as we're delivering these samples. So they're testing that there, and we're documenting that every step of the way. As I mentioned, we do a lot of live productions too. So this middle screenshot here is a live production that we did for the Lucy mission last year as we were kind of getting up to speed with the mission. And then oftentimes the biggest part of the work we do is actually creating animations and data visualizations, because unfortunately, as cool as this would be, we don't have GoPros everywhere in space to capture this amazing science as it's happening in real time. But what we do have is an incredible resource of data coming back in constantly from these spacecraft. And it's our job as communicators to try to find an interesting way to really translate that data into a finished production that will then not only communicate the science, but be engaging and visually appealing to you. So that just kind of gives you an example of how we're really able to take the science to like a new level and really push things creatively while still obviously keeping true to the science that's going on with these missions. So it's always a lot of fun and always a different case study for every single mission that we work on. And with that in mind, I kind of wanted to walk you through a case study of a particular mission, NASA's Lucy mission, to talk about how we really try to understand our audience as we're beginning these productions. So when Lucy was initially pitched to me, it's a 12-year-long mission that's going to be exploring a population of asteroids known as the Trojans that share an orbital path with Jupiter. And I thought 12 years, that's an incredibly long amount of time that people who are maybe in middle school or high school now who are going to be growing up alongside this mission might actually join our ranks at some point in the phase of Lucy's work here for NASA. And so we really wanted to pitch to that kind of next generation of scientists who are going to be joining us along the way. And so we really started to storyboard out this character that was kind of like a BB-8 R2-D2 style character to give life to Lucy and her suite of camera instruments. So Lucy has a really interesting suite of cameras that are going to be imaging these asteroids as she flies through on her long journey out to space. So we really wanted to capture this, and this gave us a chance to really flesh out Lucy's mission in such a different way through this ongoing cartoon series. So we're actually 7 episodes deep with this series now, and it's just going to continue to grow as we continue on in this 12-year-long mission. And so we've got a couple little animations here to kind of show you a flavor of what this looks like. And it's really been a massive hit with elementary school, middle school students, and it's allowed us to do a lot of engagement and outreach tied to this production, which is always fantastic, always something we love to do. And so we actually created like a little coloring book to go along with it, an activities book that has a little bit more information about the mission and some of the science that we're going to be doing, and even things like a Lucy paper snowflake to kind of give students an idea of what this spacecraft actually physically looks like. They can kind of create a little 3D model themselves. And then we have a project called the Lucy Time Capsule, where obviously 12 years, long time down the future for a lot of these kids, we want them to take stock of what's important to them right now and what their lives might be like in 12 years. And then in 12 years' time, they'll open it up and see how their lives have changed and also how our understanding of the solar system through Lucy has evolved over that time period as well. So a really fun series to work on. Another big piece of what we do is actually long-form content as well. And this is really where the people-focused stories come to life for NASA. And I've been a showrunner and director for one series in particular called NASA Explorers. And I just finished a production on one season all about the Artemis mission, where we really approach the storytelling from all angles. We worked with the tools engineer, Adam Nades, who's based at Johnson Space Center, who's designing hammers and spacesuits that these astronauts are going to be using when they get to the South Pole. We worked with an astronaut herself, Dr. Jessica Watkins, who was doing a tour on the ISS as we were creating this series. And we also worked on the back end with some astrobiologists like Dr. Jose Ponte, who is preparing his lab to acquire samples from the South Pole that will then analyze to understand even more about our moon. So these are really fun series to produce and just gives you such a different behind-the-scenes perspective into the science that we're doing. You can actually see a lot of these on Hulu if you have an account on there. We release all of them up there, but we also put them on our NASA flagship account, so I definitely encourage you to check those out. And so that is also one big piece. We also do a lot of short-form content, too, and this is, once again, kind of marketing to like the next generation of scientists and engineers. We reach a lot of younger audience through Instagram, in particular through Instagram Reels, where we create these kind of 60-second to a minute 30 long videos, often featuring a lot of our visualizations, animations, and a lot of interviews with some of our team members, and kind of a different, shorter format video as people are scrolling through their feeds. So just these quick little snappy pieces that are just really high engagement and really just another way to reach our audience. And kind of the last way that we really try to approach a lot of our storytelling is by keeping up with new tech. So I'll just have this video playing here and I can kind of talk through what we're seeing. So as I mentioned, OSIRIS-REx is on its way back with a sample from asteroid Bennu. But while it was at Bennu, it actually mapped the surface of Bennu in better detail than we have our own moon, down to about 2 centimeter per pixel resolution. And so what that's allowed us to do as visualizers is take that data and then create a 3D reconstruction of the surface in our software. And then we're able to actually bring you, the viewer, along for the ride. So what you're seeing here is kind of a stretched out version of what would be something that you'd see in a VR goggle, a VR headset, where you can actually stand on the surface of Bennu at our sample site, which is Nightingale Crater, and look up as the spacecraft is coming down to collect this sample. It's just another way to really bring our viewers along for the ride with us, especially as we're pushing deeper into space, to just really make the science more accessible and just kind of tell you the story of NASA's incredible science in such a different way. So with all this in mind, I just wanted to thank you so much for tuning in today, and I'm happy to answer any questions you have about the productions that we work on for NASA. Thank you so much. Awesome. Well, there are no questions. I'll be around as well if you wanted to chat as well. So thank you so much. Appreciate it.
Please welcome Philip McAlister, Director, Commercial Space Division, NASA HQ.
Hey, that's all right. Everybody, it's a pretty good crowd. I heard I was going after Jared. It's like, no, don't make me go after Jared. That's terrible. But thanks for showing up. So I don't oversee all of NASA's commercial partnerships, but just the cool ones, as I like to say. And in fact, we have a mission going up in just 3 days. Monday early morning, 1:45 a.m., the Crew 6 mission is flying to the International Space Station. So if you guys are in Orlando and you're awake at about 1:45, look to the east, or maybe just come on down to Cocoa Beach and you will get to see that launch. Night launches are super cool, even if they disrupt your sleep. So anyway, again, thank you guys for coming. I'm sure some of you may be wondering about the title of my remarks, the Commercial Spaceflight Revolution, Who Won? In many ways, the answer seems to be pretty clear. In the last 3 years, SpaceX has launched 8 commercial human spaceflight missions to space, including 6 for NASA. The Inspiration 4 free flying mission that Jared talked about, and also the AX-1 private astronaut mission. Soon, Blue Origin and Virgin Galactic should be flying again, and they will pretty soon have over a dozen human suborbital space flights accomplished. In addition, there are 4 companies developing and designing commercial LEO space stations, which is another program that I oversee. So in a lot of ways, the answer to my question is clear. But at the risk of becoming a buzzkill, I do have concerns with where we're going, and I want to mention some of those. But before I do that, I do want to talk about sort of how we got to where we are today and some overall observations about our industry. I would say probably about 20 years ago, there was no commercial spaceflight industry. Other than commercial SATCOM, There wasn't even really a commercial space industry. The industry was dominated by relatively few large aerospace and defense companies, the so-called traditional aerospace industry, and these companies were almost exclusively focused on the federal government as its customer. They didn't make significant investments in new capabilities, and other than some small IRAD investments, and those investments were designed to make the companies more competitive in winning government contracts. Now, those were and are good businesses. I worked for one for 10 years, and I loved every minute of it. The problem is that the industry was insulated from disruption that we see in almost every other industry. Think about the information technology industry, where you can literally start a company in your garage. As a space startup, you really can't do that. You need a large, well-educated workforce. You generally need access to large facilities like test stands, and you need a lot of property and big buildings, and these things are all very expensive. So while there have always been space startups, they have tended to flame out early because they could not raise the sufficient capital to compete with the entrenched, established companies in our industry. So without that disruption that we see in almost all these other industries, there was really no incentive for the traditional aerospace companies to change. And their focus on the federal government as their main customer ensured that space systems remained expensive because the federal government prioritizes performance over cost. And when things are expensive, it generally limits their business opportunities. There also wasn't a ton of innovation either, because the government customers, like me, we generally don't like risk. And innovation sometimes means changing things, which can come with some additional risk. But then, starting about 20 years ago, we had a relatively brief, kind of wonderful period of time when the new space industry emerged. And I've got some stats here. In 1999, Virgin Galactic was established. The following year, 2000, Blue Origin was established. Also in 2000, Paul Allen and Burt Rutan partnered up to design Spaceship One. 2002, SpaceX was established. And 2004, the Ansari X Prize was won. Virgin announced its partnership with Scaled Composites, and then 2006, you see the Commercial Spaceflight Federation being founded, and a lot of these commercial spaceflight companies came together. So there were certainly others during this period, of course, but you get the picture. In this relatively short six-year window, we saw these very unique startups emerge. And they were unique because they were mostly self-financed by very wealthy entrepreneurs. So they could blow through that funding limit that I had mentioned earlier that constrained so many of their predecessors. And they were run by successful businessmen and women, not engineers. And they brought their extensive business skills to the problems of our industry of aerospace and spaceflight. And this is the most important part, they were looking for business opportunities. They were not necessarily focused on the federal government as their primary customer, so they needed to innovate. They needed to be cost effective in order to attract those business opportunities. And that's the difference between traditional aerospace companies and new space companies. It's their business model. One is not necessarily better than the other, they're just different. And we just need to recognize that. And then after that 6-year period, we had kind of a 15-year period where the commercial revolution was fought. It was a hard-fought battle, and now we have a very, very different landscape. The dust has mostly settled. We have a larger, more diverse industry today, which I think is very positive. And I'll acknowledge that the results do seem to be clear today. There are over 80 members of the Commercial Spaceflight Federation. New startups are being created all the time. You're probably hearing from some of those in this conference over the last 2 days. And we've also seen an infusion of capital. That's come and gone a little bit. We're kind of on a dip right now, but certainly over the last 5 years, a huge amount of investment capital has come into our industry. And human spaceflight missions are occurring with regularity, as I mentioned. So why would I pose the question of who won? It's because in most of the companies that I cited earlier have pivoted toward the federal government as their focus of their efforts. I don't have exact figures because SpaceX is obviously privately held, but I'm sure the vast majority of SpaceX's revenue comes from the federal government. After years of shunning the government, Blue Origin has embraced NASA and the opportunities associated with our lunar and LEO activities. The suborbital transportation providers are starting to focus on the government sales through NASA's Flight Opportunities Program and also through the NASA Suborbital Crew Program. This is not necessarily a bad thing. For those of us in the government, like me at NASA, this is a great thing because it means more competition. And more competition is obviously a very, very good thing. The problem is that, in my opinion, the fundamental DNA of the government has not changed. There is still a strong preference for performance over cost. Not many of my NASA colleagues ask the question, is this space capability good enough? And instead, they want to specify exactly what they want with a large list of performance requirements, which makes things very expensive. And that ensures the federal government can be the only customer or one of the only customers for the eventual service. So as the companies in the commercial human spaceflight industry pivot more and more towards the federal government, I worry. I worry that they may lose their focus on cost effectiveness and business opportunities. And that's what sparked the revolution in the first place. If that happens, we will have just traded one set of companies for another. So that's what I worry about. Now, to keep that from happening, all of us in the commercial human spaceflight community must keep obsessively focused on cost effectiveness and business opportunities. That's what will expand our industry. Otherwise, the industry will always be constrained by the size of our federal budgets. The Commercial LEO Destinations Program that I oversee is a perfect example of this, and I think this program represents the most significant commercial space opportunity for the next decade, and it's going to be very telling to see how that plays out. So while the revolution may be over, there's still a lot of work that still has to be done. We have Starship coming, promising to further reduce transportation costs. We need a Starship competitor, or two. We need a cost-effective spacesuit. We need a cost-effective docking adapter, and we need quick and easy way to get stuff back down to Earth, and we need a better toilet. These things represent business opportunities, and they're just waiting for some disruptor to come in and disrupt the heck out of them, and that's what we really need. So my advice to my colleagues in the private sector, if you're out in the private sector and you're in some company, whether traditional or new space, my advice to you is don't look to the federal government to close your business case. Focus on cost effectiveness and business opportunities, even as the siren song of government sales gets louder. For those of you in the government sector, if there's any of my compadres that are working for NASA or DoD or other civil agencies, the trend has obviously been sort of away from cost plus contracting and more towards fixed price contracting. Before commercial cargo, fixed price development was almost never considered by NASA for human spaceflight systems. And now almost every major human spaceflight contract since SLS and Orion has been fixed price. This is a huge change for those of us in the federal government. It's a significant development because cost plus contracting, while it's appropriate for certain things, it really eliminates almost all the incentives for cost effectiveness. And so what I worry about here, because I'm kind of a worrier, unfortunately, is that my colleagues in the government will assume that fixed price contracting will just fix all the performance issues and cost overruns that we have experienced over the years. But managing fixed price contracts is very difficult unless you focus on these four things. Number one, this is kind of boring, but it's very, very important. Your requirements must be mature and stable. If you are constantly changing your requirements, then you might as well just have a cost plus contract because you're going to have to pay for every contract change. The required technology that you need needs to be relatively well understood. If you're pushing the state of the art technologically, the private sector can't estimate their costs with a high degree of precision, and they're not going to enter into a fixed price contract because they could bankrupt the company, and that's totally understandable. That's why what I mentioned earlier is that the Commercial LEO Destinations Program is very significant. We've been operating in LEO for over 20 years, continuously. We don't necessarily need better technology, we just need better innovation, better cost effectiveness, better efficiency with our spaceflight systems in LEO. Number three, and this is the one that's toughest, I think, for NASA, is the NASA oversight must be kept to a minimum so that the companies are allowed to innovate and be cost effective. Without this, industry's incentive for entering into a fixed price contract just evaporates. And that one is tough because in the 40, 50 years of NASA's experience and existence, we have always been in charge. We have always dictated the solutions. We've owned and operated the hardware that has been resulting. And so it's been a big change for NASA. We've come a long way, but we have a long way to go, I have to say. And whenever possible, this is number 4, pick multiple companies. Without competition, if an issue pops up that costs money, then it's going to lead to a contentious battle, which will stretch out the schedule, add to costs, and it's just a spiral from there. So I feel like if we do these things, if the private sector continues to focus on cost effectiveness and the government is careful with fixed price contracting, then the answer to the question that was the title of my speech, who won, will be clear. Thank you very much. Happy to take questions. All right, everybody's getting hungry for lunch. I'll answer quick if you have a quick question. All right, thanks everybody. Appreciate it.